Hello boys and girls, a very good morning and welcome to this live doubts clarification session on quantitative aptitude and reasoning ability brought to you by Talent Sprint. I hope all of you are in good health. I hope that all of you have done well in your IBPS clerks exam which concluded last week, and I'm sure your preparation for the upcoming exams is in high gear, right? You know that the next exam lined up is the RBI Assistant's main exam, right? And I'm sure your preparation for the same is going fine, and then it will be followed by maybe the IBPS SO exam, which is expected to happen on 31st of December, right, the end of this year. And then what comes next is the IBPS clerk's main examination, right, which is Jan 26th, the tentative date. Anyways, so the point that I'm trying to make is many exams are lined up. Irrespective of how you have performed in the preliminary examination, I think you should continue with your preparation. All right, and yes, there will be a host of exams in the year 2018 as well, which is just a couple of weeks away, and I'm sure all of you are excited about the same, right? And then the SSC CHSL examination notification for which has already been released. If I'm not wrong, 18th of December is the last date to apply for this exam. So you have 2 more days to complete your application if you have not done it already. So make sure that you apply for this examination and keep preparing. It is coming up in the month of March, so you have enough time to get fully geared up for this examination as well, right? So I think that's the update on the exams which are lined up. A couple of more updates I have for all of you is on your discussion forums, right? I hope you have started getting quicker responses to your questions through the discussion forum, right? Gayatri and her team are making sure that they answer the questions as early as possible through the forum itself, so that you don't really have to wait for these weekend doubts clarification sessions, right? The other point is, if you have observed, we have started sending out emails on the questions which are being answered in the discussion forum, right? So maybe twice a week we'll send out an email with all the links which have been responded to in the quantitative aptitude, reasoning ability, and the English language discussion forums. So please go through those emails. The idea is to make the discussion forums even more engaging, right? And to take the participation rate up, so that overall the turnaround time for anything that you post there should be very good, right? So please make sure that you participate more and more in the discussion forums and enjoy from learn from your peers and enjoy the learning there, right? And yes, I also hope you have been attending the instructor-led live sessions which are being held on the Mondays, Wednesdays and Fridays every week on all the subjects relevant to your bank exams, right? One last update before we actually get into solving these questions. Looks like I've met you after a long time. I don't know why I'm feeling that I'm taking a live session after a huge gap, right? At least it feels so, right? So the last update I have for not for all of you, but for those who have enrolled for our SSC exam prep program, is about the new videos that we have published in the general awareness section, right? All those who have enrolled for SSC exam prep program must have observed that a lot of new videos are getting released in the general awareness section. This is based on the feedback that we had got from you, right? The feedback was that the content in general awareness has to be of better quality, both in terms of the subject matter and also in terms of the video quality. So we have worked on that, right? And our new colleague Sridhar is recording many videos for all of you across all the subjects. So we have started publishing videos on I think polity and economics, right? And we'll be soon adding videos on the other sections as well, right? Which includes history, geography and the general sciences. So I would request all of you to please go through that content, go through those videos, right? Along with the videos we have PDFs, downloadable PDFs available for you, and also the quizzes which are going to be added soon. So please go through those videos, go through the content and share your valuable feedback with us, so that we can improvise it further if there's anything required. Okay, so with that, I think I'm done with my updates. Let's get started with your doubts clarification session. I'll have a mix of questions today from quantitative aptitude and reasoning ability. You may find some questions to be really very silly, some questions to be very complex. The idea is to keep everyone confident that yes, your questions are also getting answered, right? So maybe a couple of questions that you see here could be very, very easy, but what we have seen in the past is sometimes even in these very simple questions, many of you fail to get the wrong answer because you think it's very easy, I can do it, and in that overconfidence you screw up somewhere. So it'll be good if you also discuss some very simpler ones, right? So let's get started. If you're all ready, I can see that many of you have joined the chat already, right? Rubini Shekhar says, please explain about the concept of distribution from average. I think I have got a couple of questions on average today. We will try and learn the concept through that. But anyway, videos are there in the averages topic. Please go through that and learn from the same. Yeah. Yeah, I think we have many others here. Shakti, Jhansi, Shekhar, Pavani. We have Kiran Surya, Anjane Upadhyay, Pratima, and others there, right? Prerna, Fatima. Then we have, okay, this is a little difficult to pronounce, but Ching K Laishram, huh? I'm here for the first time, so welcome to Talent Sprint, and I hope you enjoy your learning with us here, right? Okay, so should we get started now? Are you all ready? Sajid says, how are you? Well, I'm very healthy, Sajid. Thank you for asking the same, and I hope the same with all of you on the other side of the screen. Yeah. Should we start now? I have a presentation here with some questions. I can just share the screen. Yeah. Kiran says, I am here also for the first time. Good. Welcome to all the new joinees, new students, and I'm sure you'll have a great learning experience with us. Please keep sharing your valuable feedback, right, and help us improve. Okay, so I've got a lot of acknowledgement there. Let's get started now. Presenting the first question to you all. This is from Quantitative Aptitude. This is from Reasoning Ability. To be specific, it is from the topic of ranking and ordering, and a very, very simple question. If I'm not wrong, I've already solved this one many times in the past. The same question with the same values, but the only reason I'm taking it up is because Shakti Jhansi wants me to explain this in the pictorial form. I think that's the only reason I've taken it up. So don't feel that this is such a silly one. It's a piece of cake. Why are you solving it, right? Let's see what happens. How does it help Shakti if I do it in the pictorial form? So I'm presenting the question to all of you. It will take about 30 seconds for you to arrive at the answer. Do that very quickly, and then we will look at the solution. Okay, here we go. So this question was posted by Shakti Jhansi, who I think is in the session here. So why do you want me to explain this in the pictorial format? Sorry. Why do you want me to explain this in the pictorial format was the question. Let's use this purple or ultraviolet kind of a color. Anyway, yeah, so the question here reads, in a class of 40 children, Sunetra's rank is 8th from the top. Sujit is 5 ranks below Sunetra. What is Sujit's rank from the bottom? Options have been given to you. Can you please explain this question by pictorial form? So I'll do that in the pictorial form, but I don't think that's any helpful. Okay, looks like Kiran has got some challenge here. He's saying that he's able to see the, he's actually seeing the current affairs session from yesterday. Kiran, I think just log into the right course. Anyway, there's no point in me talking to him because he's not seeing me. He's not able to hear me. But yeah, good that you guys are helping him out through the chat. Okay, answers here. 28, yes? Yes, many of you have answered 28. I'm sure Shakti has also got the same answer, but let me solve this in the pictorial format. Okay. Here we go. Now, the question here says, in a class of 40 children, Sunetra's rank is 8th from the top. Sujit is 5 ranks below Sunetra. What is Sujit's rank from the bottom? Now, in the SMART method that we have discussed, how do we solve it? We know that the total number of students or total children is 40. Sunetra's rank is 8th from the top. Sujit is 5 ranks below Sunetra. So, what will be Sujit's rank from the top? What will be Sujit's rank from top? Sujit's rank from top will be, see, 8 is Sunetra's rank. Sujit is 5 ranks below Sunetra. So plus 5. 8 plus 5, 13. So basically in a class of 40 children, Sujit is 13 from top. What will be Sujit's rank from bottom? So it's like you have been given the rank from one end. You have to find the rank from the other end. Position from one end is given to you. You got to get the position from the other end. How do you get it? Sujit's rank from the bottom. Don't write all this and waste your time in the exam. Huh? You just play with numbers. So how do you get Sujit's rank from bottom? 40 minus 13 plus 1. So 40 minus 12. 40 minus 12 is 28. And that's your answer. That's what all of you have got. Should not take more than 10 seconds for you in the exam, right? And cut down the number of steps that you put on paper. I don't think any of these steps are required. You can solve this mentally, right? 28 is going to be the answer. Now let me explain this to you in the pictorial format as requested by Shakti here, right? So pictorial form, I don't really understand what is pictorial form, but let's do it this way. Let's say the 40 students are ranked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why did I put all these dots? 11, 12, 13, 14, 15, and so on up to 40. Right? In a class of 40 children, Sunetra's rank is 8 from top. 8 from top. What is 8 from top? This is Sunetra. Sujit is 5 ranks below Sunetra. 5 ranks below Sunetra. So 1, 2, 3, 4, 5. This is going to be Sujit's rank. What is it? 13. 13th is Sujit's rank. What is Sujit's rank from the bottom? From the bottom, you have to count from 40 now. Now don't think if it is 13 from top, from the bottom it is going to be 40 minus 13, 27. If that is your confusion, go watch the video again. 27 cannot be the answer. I've explained this very clearly in the ranking topic, right? You cannot take 40 minus 13 as the answer, right? If you take 40 minus, see what happens if you take 40, from 40 if you remove 13, you're removing all these numbers, you're removing all these positions. Up to what? Up to 13. You're including 13, you're excluding 13 as well. But should we exclude 13? No, 13 should be a part of it, right? 13 should be included in the group. So 40 minus 13 plus 1, because this position has to be added. That's why we do 40 minus 13 plus 1. Anyway, Sujit's rank from bottom, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You do all the drama till you reach at 13. That will give you 28 as the answer. The shortcut for that is this. Instead of counting, you say 40 minus 13 plus 1. 28. 40 minus 13 plus 1. So 27 is not the answer. 28 is the answer, option 3. And this I assume is the pictorial form which Shakti was looking for. Now, because Shakti is here in the session, can you quickly confirm if you have understood this so that I can move to the next one? Yeah? Can we go to the next question? Shakti, waiting for your confirmation. Shakti says the sentence is not clear to me. Sentence, I guess, is pretty clear, no? Sunetra is 8 from top. Sujit is 5 ranks below Sunetra. Got it? Okay, she's got it. So let me present the next question to you. Now this is very interesting. This is posted by Ashutosh Kumar in the reasoning course, discussion forum of reasoning. And this is like a puzzle. I don't think it will be asked in any of your competitive exams because this needs an explanation. You just cannot give an answer in terms of it cannot be an MCQ basically. Yeah, he says there are 2 mugs, one with 4 liters and the other with 5 liters capacity. How will you pour exactly 7 liters of water? You're being given 2 containers. So one container can hold 4 liters, the other container can hold 5 liters. You got to measure 7 liters. Let's say I'm a milkman. I've got 2 of those. What are those called? 2 of those mugs, let's say big size mugs. One can measure 4 liters, the other can measure 5 liters. The customer says I want 7 liters. How am I going to give him 7 liters? Using this 4 liter and 5 liter capacity mugs is the question. Now this cannot be an MCQ question, right? I mean, you need an explanation for this. Now, again, while I am saying that it is not relevant to bank or SSC exams, the reasoning is important. You should build that reasoning, right? It will help you. So that is the reason we have taken it up and presenting it to you now. Give it a try. I'll leave you with this for maybe 1 minute, 1 to 2 minutes. Think about this. How do you get 7 liters? Using measures of 4 and 5. Think about it. Explain that to me in the solution. You don't say I've got it. I want you to explain that, right? I want you to explain that in the chat. So try this out before we discuss the solution. 4 liters and 5 liters. You have to measure 7 liters. So basically the customer has got a big pouch, let's say. It can hold any quantity you want. How will you give him exactly 7 liters? Pavani says fill the 5 liters first and then fill the 4 liters up to half. No, but how do you measure half is the question. No. See, you cannot be giving even 1 ml less or 1 ml more. There are no markings there. It can measure 4 liters or it can measure 0 liters. The other one can measure 5 liters or 0 liters. It cannot measure 2.5. Markings are not there. Think about this. Very interesting question. Again, while not relevant to your exam, it will help you build your reasoning skills. I can see solutions coming in. Remember, there can be multiple solutions, right? There need not be a unique solution to this one. I am waiting for more answers to come in before I take this up. Got it? Okay, let me just come back to the video and read out a few solutions here. Let's see what have you all got. Okay, right, so Sai Kishore has given one solution. He says 4 into 3 minus 5 is 7. Well, that's one way that it works, right? 4 into 3 minus 5 is 7. So what do you do here? 4 into 3 minus 5, what do you understand? I've got it. See, understand guys, many of you have said that you can take half of 4 liters, which is 2 liters. How do you measure half? How do you know it's exactly half? There are no markings there. It's a plain 4 liter container. There are no markings. And the idea is, you cannot say roughly half and all that. We need a precise semi-liter quantity. Okay. So there are many possible answers, like I've already told you. But yes, one way to do it is 4 into 3 minus 5. So 4 times 3 is 12. Minus 5 will give you 7. What do we do? You take 4 liters 3 times. 4 liters, 4 liters and 4 liters. That makes it 12 liters. See, there is one place where you can accommodate as much as you want. The whole idea is you should use only these 2 containers. So you pour 4 liters 3 times, that will make it 12 liters. So from that 12 liters, remove 5 liters using the other mug that you have, 5 liter mug, 5 liter container that you have. So it had 12, you'll remove exactly 5, right? Exactly 5 from it. So 12 minus 5 gives you 7. That's one way of doing it. Let me just look at the other solutions. Yeah. Or you can look at it differently also. Instead of saying 4 into 3 minus 5, it can be like 4 plus 4. You put 4 liters first, again put 4 liters, that makes it 8. From that you remove 5. 8 minus 5 is 3, and then add 4 back. It's the same. The only thing is you are interchanging the steps. Final quantity that you get is 7 liters there, right? We have one solution from Matthew Varghese here, who says first fill 5 liters in 5 liter jar, pour it into 4 liter one, 1 liter will remain, add it to 7 liter container 7 times. Well, that's one way of doing it. Makes it really a long process, but yeah, the solution is correct. What is he saying? Pour 5 liters in a jar, remove 4 liters from it, you will be left with 1 liter. Give that 1 liter to the customer. Repeat this process for 7 times, you'll get 7 liters. Yeah. Divya has given a solution. 4 plus 4 plus 4 plus 5 minus 5 minus 5 equals to 7. Why do you want to do plus 5 minus 5 minus 5? Only 1 minus 5 will help you, right? Divya, 4 plus 4 plus 4 is fine, but then you have said plus 5 minus 5 minus 5. That plus 5 and minus 5 anyway are getting cancelled, right? So directly 1 minus 5 will help you, right? I mean, subtracting 5 ones will help you. Yeah. Satish Kumar has given a solution. He says first give 5 liters, then take 5 minus 4, 5 minus 4 twice, 1 liter. Yeah. So I think it's all about arriving at the number 7 using 5s and 4s, using 5s and 4s, right? Remember, you cannot do half of 5 or half of 4 or 1/3 of 4 and all that. You just have to use plain additions, subtractions for arriving at the answer. Okay. So Pavani, where you said 5 liters vessel first, fill the 5 liters vessel first and then fill the 4 liter vessels up to half. How do you measure up to half was the question. So your solution is invalid because I don't know what is half of 4 liters. I mean, I cannot fill it up to half. There's no marking there. Okay. So guys, when you have to answer such questions, just remember one point that I mean, there can be other solutions as well, many other solutions that I'm not reading out all all of them. But the point that you have to remember is just try and use additions and subtractions. Like 4 into 3 minus 5 also is correct, but you say 4 plus 4 plus 4 minus 5. Yeah, because only using additions and subtractions. You're adding either 4 or adding, what can you do? You can add 4, you can subtract 4, you can add 5 or subtract 5. So just keeping that in mind, arrive at the number 7. Okay, so I don't really have to explain this on paper. You have understood this from your solutions there. So let me just go to the next one. Yeah. Now here's the next question. This was posted by Rishu Goel. It was posted in the Quantitative Aptitude course of SSC exam prep program, right? This is a simple question on average. Let's see how quickly do you arrive at the answer. Calculation is the key here, right? He says there are total 600 students in a school. Average age of boys is 12 years and of girls is 11 years. While the average age of all the students is 11 years and 9 months. Find the number of girls in the school. Find the number of girls in the school. So how quickly do you solve this is the question. I'm sure solving this is not a big deal. You can all get the right answer, but how quickly do you solve? How do you work with the numbers is what you have to look at. So try it quick. Quick, you have 10 more seconds. You should have got the answer by now. Work on this very quickly. $150. 140 is also one of the responses here. All right, so let's discuss this now. I think enough time has been given. Most of you have got the right answer. It should be 150, and I think I can say that without putting pen on paper. I'm sure you guys have also not really done much of paperwork there, right? Remember the point that I'm making here. You can solve this question without putting pen on paper. Here we go. Look at the solution. So the question was posted by Rishu Goel. It says there are total 600 students in a school. Average age of boys is 12 years and of girls is 11 years. While average age of all students is 11 years and 9 months. Find the number of girls in the school, right? So simple question, total 600 students. Let's assume the number of boys are B and the number of girls are G. So B plus G is equal to 600. Statement number 1, equation 1, right? Next point, average age of boys is 12 years and of girls is 11 years. While the average age of all the students is 11 years and 9 months. Now, I think one of the important parts of the solution is how do you convert 11 years and 9 months to years? See, you have to balance the units on all the places, right? 12 years is in years, no problem. 11 years is also in years, but here we have got 11 years and 9 months. But understand, 9 months is equal to 0.75 year. 0.75, 3/4 of a year, right? 9 months is equal to 3/4 of a year. It can be taken as 0.75 of 1 year. So 11 years plus 0.75 of a year. So 11.75 years. You're getting it? 11 years and 9 months can be treated as 11.75 years. 11.75 years. So for boys, the average age is 12 years. For the girls, it is 11 years. And for the whole class, including boys and girls, is 11.75 years. Right? Now, you know that average is all about balancing. It should be equal on both the sides, right? Equal distribution, like we say. Here, what you have to do, total age of the boys and total age of the girls should be equal to total age of the entire class. Total age of boys plus total age of girls is equal to total age of the whole class. Now, what with the total age of boys? There are B boys and average age is 12 years, so 12B. What with the total age of girls? There are G girls and average age is 11 years, so total age of all the girls will be 11G. You understand? Average is equal to sum by number of persons. So sum will be equal to average into number of persons. So average into number of persons is the sum of the ages of boys. Average into number of girls is equal to the sum of the ages of the girls. Should be equal to average 11.75 into the number of persons B plus G, which is equal to 600. You're getting it? So 12B. So basically this equation has to be solved. 12B plus 11G equals to 11.75 times of B plus G. Now a smart solution will be as follows here. Instead of using 12B plus 11G, this 12B can be taken as B plus 11B plus 11G, which is equal to 11.75 times of B plus C. You understand? If I take 11 common, this is like 11 times of B plus G equals to 11 times of 11.75 times of B plus G. Yeah. So basically B will be equal to, you understand? I can take B common here. I can take 11 common. So this becomes 11 times of B plus G. On this side, we have 11.75 times of B plus G. So 11.75 minus 11 times of B plus C. You can cut down the number of steps. I'm writing all the steps so that you can follow the solution clearly, right? You don't have to write all the steps here. Now substitute. So what is the number of boys? Number of boys will be 11.75 minus 11, 0.75 into what is B plus G? B plus G is 600. 75% of 600 is 450. If number of boys are 450, obviously the number of girls are 600 minus 450, which is 150. So your answer should be 150. Your answer has to be 150. You're able to follow? So therefore, the number of girls, don't write all this, but answer is 150. Number of girls is equal to 150. That's your answer. Okay. So this is how you solve it. Please remember, you can cut out at least 2-3 steps from this one, right? You don't have to write everything. Like B plus G equals to 600 is not really required. This is the most important equation. This you have to write properly. And then, ensure that you take 12B plus 11G as B plus 11 times of B plus G. Okay. Now, let me take another example. What I'll do is, instead of 11 years, let's take another example. For the same question, just change the value somewhere. Instead of, let's change 11.75 to 11.25. 11.25 assumption. And solve the same question. What happens? This will help you understand something, right? So what happens? We will say 12B. Still, everything else remains the same. 12B plus 11G equals to 11.25 times of B plus C. So now you have understood. We'll get B plus 11B plus 11G. So 11 times of B plus G. So B equals to 11.25 minus 11. 0.25 times of B plus G, which is 600. This is how you would solve. I mean, if you cut down the steps, these are the only steps that you'll put on paper. You understand? The average of the whole class is 11.25. 12b plus 11g, right? So 0.25 into 600 is how much? Is 150. So number of boys are 150, implies number of girls would be 450. In this case, number of girls will be 450. Now, why did I do this? What do you understand from this? See, look at it. What we know here is that the average in the initial case was 11.75. See, one interesting point to be noted here is that the average age of boys is 12 years and the average age of girls is 11 years. Right? Average age of boys is 12 years and that of girls is 11 years. Yeah. So there's a difference of only 1 unit between these two. And the average of the class is 11.75. You getting it? Let me use the third color now to explain you how do we actually work on this very smartly without having to put pen on paper. Average of boys is 11. Sorry, average of girls is 11. Average of boys is 12. And the average of the entire class is 11.75. See, try and understand, if you look at it, the average 11.75 is closer to the average age of boys or average age of girls? It is closer to the average age of boys. Yes or no? This is girls. This is boys. Right? So girls is 11, boys is 12, average is 11.75. Is it closer to boys or closer to girls? It is closer to boys. It is closer to boys. If I look at this distance of 1 unit, 11 to 12 is 1 unit, right? This is 11.75. It is like 75% towards boys. 75% towards boys. Yes or no? 11.75. 0.75, look at that extra part, 0.75. Out of this 1 unit, out of this gap of 1 unit between 11 and 12, 0.75 towards boys. That means 75% are boys. So out of 600 students, 75%, 450 are boys. Remaining 150 are girls. Look at the same thing here. When I change the average to 11.25, if I assume it is 11.25, so what happens? The girls' average is 11, boys' average is 12. Right, the overall average is 11.25. This time it is closer to the girls. It is closer to the girls. Yes or no? It's closer to the girls. You getting it? It is closer to the girls. Average is closer. 11.25 is close to 11 or close to 12? It is close to 11. 11.75 was close to 12, but it is close to 11. See, what does it mean when I say 11.75 is closer to 12? It means the weight of boys is more. Weight of boys is meaning the quantity of boys, the number of boys, the strength of boys is more than the strength of girls. The strength of boys is more than the strength of girls. That is why the average is, towards the boys and not towards the girls. See, try and understand the fact. If average age of girls is 11 years, average age of boys is 12 years, and average of the whole class is 11.5. What do you understand from this one? This all of us know. What do you understand from this one? 11.5 is exactly between 11 and 12. There is a group, that group's average is 11. There is another group, this group's average is 12. The overall average of both the groups is 11.5. Now 11.5 is exactly between 11 and 12. What do you understand from this? This shows us that the strength of the first group is equal to the strength of the second group. This can happen only when the number of boys and number of girls are equal. Only when the number of boys and number of girls are equal, then the average will be exactly in the middle of 11 and 12. Here, the average is more towards the boys, which means the number of boys are greater than the number of girls. Here, the average is more towards the girls, which means the number of girls are more than the number of boys. Number of girls will be more than the number of boys. Now, how do you understand that? See, average is shifting towards the girls' side. Yeah? Average here is shifting towards the girls' side. Again, now this time you can't say because it is 25%, so take 25% of 600, which is 150 as girls. It is towards the girls' side, right? So, I mean, basically the idea is you have to divide. See, when I said 75% here, the groups are 25% and 75%. 11.75 means what? One group is 25%, the other group is 75%. Which group will be 75%? Obviously, boys will be 75% because boys are more. That is why the average is more towards boys. 25% will be girls. Here also when it is 11.25, the breakup is like 25% and 75%. So 25% is one group, 75% is the other group. But which is the girls group? 75%. Because then the average will fall towards girls, right? So this is for girls and this 25% is for boys. So if you kind of build this understanding, you will be able to solve this without putting pen on paper. Of course, there are some advantages here. The value for girls is 11, that for boys is 12. So it is exactly 1 unit, right? So not a problem. But suppose if this is 11 and 13, then it will become 2. The difference will become 2. Right? Then 11.75 does not mean 75% and 25% groups. then it would mean 37.5 and 62.5. You know, that numerical skills are required. I mean, that's why I always say play with numbers. If you can play with numbers, then things becomes a lot easier for you. Anyway, even if you go by the conventional methods, I mean, this is not a conventional method. Even if you follow this solution, you will get the answer really quick. But the idea is, the moment you look at these numbers, right, 11, 12, 11.75, you should know that, okay, the number of boys are going to be more, because the average is towards the boys side. So take 75% of boys. If it is towards the girl side, take that percentage for the girls, and you'll get the answer. Okay. All right. So that's the solution for this one. The final answer for the number of girls in the school is 150. I hope all of you have followed this. If you're all clear with that, we can take up the next question. Yeah. Should we go for the next one? Allegation concept. Yes, that's the allegation concept. I mean, you remember, you can also solve this question using the allegation rule. That's what we are doing here. Mahesh Kumar has pointed out. I mean, I hope all of you have understood, right? That's what happens in allegation, right? I mean, if you see the way the presentation also was, one side boys, the other side are girls. In the middle, we write the average value, and we take the ratios, right? Difference of these two will be given for boys, and difference of these two will be given for girls. That's what is happening here. Followed? Yeah. So let's move to the next one. Again, the next question is very simple, and in fact, I remember that I had solved this in the very old video that I had done on percentage, the very first few videos of percentages. But Shubham wants me to give the solution by conventional method because he's not getting the right answer otherwise. So let me present this to you quickly. He says the sale of a company N is 40% less than the sale of company T. Then by what percentage is the sale of company T more than that of company N? 66%, 20%, 40%, 10%, none of this. He says, please give the solution by conventional method. I'm getting 40% answer every time. And by other method, I'm getting the correct answer as 66.66%. He's a little confused. So let me clear his confusion, right? I'm not sure why he's getting confused. By conventional method, he's getting the answer as 40%. 40% is a stupid answer, let me tell you. It's a dumb answer. If the sale of company N is 40% less than company T, then the sale of company T will not be 40% more than company N. This is given. 40% is definitely not the answer. You can mark 10%, I would be okay. You can mark 20%, I'll be okay. You can mark 66%, I'll be okay. But marking 40% to this one is definitely a very stupid step, I would say, right? It cannot be. If my salary is 20% less than your salary cannot be 20% more than my salary. It will be a different percentage. See, numerically, absolute values will be same. If I am earning 2,000 rupees less than you, then you will be earning 2,000 rupees more than me. But if I am earning 20% less than you, does not mean that you are earning 20% more than me. Right? So how do you solve this? Simple. Sale of company is 40% less than company T. Company N and company T. Let's assume company N is earning, the sales are 100. What will be the sale of company N? 60. So 40% less than company T. Yes or no? If this is making 100, this is making 60. How do you check what percentage less? N is what percentage less? See, how do you check N is what percentage less than T? I have given this equation, right? Remember the fundamental technique, or not the technique, actually the concept of percentage. X is what percentage more or less than Y. How do you solve this? X is what percentage more or less than Y? X minus Y by Y into 100. You know where are you going wrong, Shubham? You're always taking the denominator as, you're not taking the correct denominator. The denominator will be Y. Your comparison with Y, right? You're comparing it with Y. So denominator should be Y. X is what percentage more or less than Y? X is what percentage more or less than Y? Your answer will be X minus Y by Y into 100. X minus Y by Y into 100. X minus Y by Y into 100. Now it can be plus or minus. It can be, you may get a positive answer or a negative answer. Positive or a negative answer. Positive or a negative answer. I have got feedback that the voice is breaking. I am really sorry about this. Good that I looked at the chat, I was so glued in the screen that I was not looking. Voice is not clear? What happened suddenly? Yes, I think it started with Mahesh mentioning that there is some disturbance in the sound, followed by Ankita Sharma, followed by Fatima, Kiran, Kirti, Sajid, Anil, Naveen. Is it still unclear? I have not done anything. मैंने कुछ नहीं किया. Still unclear? How did it suddenly build this echo or whatever the problem is? Okay, I guess you have to allow us a couple of minutes. If you can quickly check and let me know if it's still unclear. Is it still unclear? Yeah, it's still breaking, I guess. Matthew and Shanmu. Okay. Oh, why does this happen in my session? Okay, give us a couple of minutes. I would request the support team, the technical team, to quickly get into the studio and fix this problem. I am sure you guys are checking me. Please check this problem. So guys, you have to allow us a couple of minutes. I'm really sorry about this. Apologies for the inconvenience caused. Let us quickly check this and get back to you, right? Just a second. All right, guys, mic check. 1, 2, 3. That's how they check. I don't know why. Okay. I just hope that the issue is fixed now. I really don't understand why does it always happen when I'm taking a session. If you can quickly, yeah, I should be speaking something continuously. So if you can quickly acknowledge on the quality of audio, it'll be great. Is it fine now? Can we get started with the session? Can we resume the session? Yes. All right. While I'm happy that it's got fixed, I'm still not sure why did it happen in the first place, because let me tell you, we actually did not do anything. We found nothing wrong with the equipment or the setup here. All we thought to do is just start it again. So got to find out what's actually happening. Anyways, without wasting a second anymore, let me quickly present the question that we are solving. We'll look at the solution and then move to the next one, right? So here we go. I think we're solving a question on, yeah, the one that was posted by Shubham. Here we go. So let me explain this to you, right? I'm sure all of you have got the right answer, which is 66% or 66.66% to be precise. But like you all can see, Shubham's queries, he's not able to solve it using the conventional method. So the question here is this: the sale of company N is 40% less than that of company T. Then by what percent is the sale of company T more than that of N? Right? The sale of company N is 40% less than that of company T. Then by what percentage is the sale of company T more than that of company N? Options, as you can see, are given here. Shubham's concern is that he wants a solution by conventional method because he's getting the answer as 40% every time. See, the Shubham, the point that I also made earlier was that 40% is the dumbest answer that one can give to this question. If the sale of N is 40% less than T, T's sale cannot be 40% more than N, right? It can be anything else, but it cannot be 40%. Again, it cannot be anything else also. It has to be one specific value, but it cannot be 40%. See, if N is 40 sales more than T, then T is 40 sales less than N. But if N is 40% more than T, then T cannot be 40% less than N. Now, all you have to remember is this concept. X is what percentage more or less than Y. X is what percentage more or less than Y. How do you solve this? X minus Y by Y into 100. X is what percentage more or less than Y. X minus Y by Y into 100, right? I mean, if you have to follow the conventional method. And this can be plus or minus. Remember, you can get a positive or a negative answer. Positive means X is more than Y. This will give you a positive answer. If you get a negative answer, don't panic. It means X is less than Y, right? So here, the sale of company N is 40% less than that of company T. See, let's assume the values are N and T respectively. So T is 100 and N is 60. So what happens? You can see it is 40% less. T is 100. So N should be 60, right? So 40% less. 40% of 100 is 40. So 100 minus 40 will give you 60. Now the question is, by what percent is the sale of company T more than N? Remember, by what percentage is T more than N? T is what percentage more than N. How should you solve it? See, than Y, you are comparing with Y, so Y should go in the denominator. So T is what percentage more than N? T minus N by N into 100. T minus N by N into 100. What is T? 100. What is N? 60. What is denominator? 60. Denominator should be taken as 60. You are taking the denominator as 100. That's why you are getting a wrong answer. So 40 by 60. This will be 40. 40 by 60 is 2 by 3. 2 by 3, 66.66%. I mean, approximately you can say 66%. Or you have to be very precise, you can say none of this. But the point is, answer is 66.66%. It cannot be the same answer, right? Both the sides, it cannot be the same answer. If one is 40% more, the other has to be something else. And if you follow the SMART method, you need not even use this concept, right? What do we do? 40% convert to fraction. 40% is 2 by 5. You want something by what percentage sale of company more? You want 2 by 5 to be more. Reduce the denominator. So 2 by 5 will become 2 by 5 minus 3. It becomes 2 by 3. Sorry, 2 by 5 minus 2. It becomes 2 by 3. 2 by 3 is 66.66%. I'm sure some of you have not followed what I'm telling here. go watch the video again. I have explained the smart method, right? This is the regular way of solving it. In a smart method, you can just convert the percentage to fraction, change that fraction depending on the question there, and get the required answer in a few seconds. Okay, let me now show the next question to you all, right? Let's take up something on reasoning, syllogisms maybe. Here we go. The first question from syllogisms for the day today is on your screens now. This was posted by Anita. It's reverse syllogism, in fact, right? Reverse syllogisms. Reverse syllogisms. Some balls are bat, no stump is a bat. So no stump is a ball. Statements have been given to us. We are required to find out which set of statements would follow for the given conclusions. All right, time is up. I can see that many of you have got the answer and most of you have marked option C here, which is some bat are ball and no ball is a stump, right? Option C is what seems to be the answer here. But then there are some concerns which have been raised by Pavani. Pavani says both C and D seems to be correct. Okay, so Pavani's view is that C and D both are correct. Prerna says I'm doubtful about D though. Yeah, and then we have Lakshman who has got D. Harish has also got D, and so has Kiran and Ashish. Good. So I think many of you have got C here, but some of you have mentioned that C and D both seem to be correct. So let's look at the solution now. Here we go. So the question was posted by Anita. Reverse syllogisms, as you can see. Conclusions have been given. We have to figure out which set of statements would give us the given conclusions. Now, what are the conclusions? Some ball are bat. The first conclusion is some ball are bat. The second conclusion is no stump is a ball. Some ball are bat, and second one is no stump is a ball. No stump is a ball. Okay. Now you can maybe draw the diagram for these conclusions, but there are some ways where you can eliminate some of the options. I mean, since there are only two simple conclusions, I can directly look at the statements and see if something can be eliminated. See, some ball are bat, some balls have to be bat. So anywhere if you find a conclusion where ball and bat are not connected at all, right? Or vice versa, like if you look at the second conclusion, it says no stump is a ball. So if you find a statement where stumps and balls are connected, such statements can be eliminated, right? So let's just quickly run through the statements and see is there anything that can be removed. Like look at the first one, right? A, option A. Some ball are stump. Some ball are stump. See, the conclusion clearly said no stump is a ball. If no stump is a ball, then no ball is a stump. No stump is a ball means no ball is a stump. What is given here? Some ball or stump. Is it possible? Not possible. So A is ruled out. A is ruled out. Then B says no ball is a stump. No ball is a stump. Fine. Some stump are bad. We'll have to figure out, right? Some stump are bad. But again, if you have practiced enough questions on syllogisms, you would know that even B does not follow, because by drawing the diagram for B, we cannot conclude that some ball are bad. Like if I have to draw the diagram for B, no ball is a stump, no ball is a stump. How do you draw? No ball is a stump. So this is ball, this is stump, no ball is a stump. Fine. These two will not overlap. Some stump are bad, some stump are bad, some stumps are bad. The conclusion says some ball are bad. Can we conclude that some ball are bad from this one? No. So first conclusion fails here. Some ball or bat fails here. See, that's the point, right? Conclusion says some ball or bat. From the statements, there is no connection between ball and bat at all. No ball is a stump. Some stumps are bat. So if you can get that visualization, you can eliminate even without drawing this Venn diagram here. Look at C, conclusion C. Some bat are ball. No ball is a stump. Well, for this diagram is not needed. It looks like this will definitely be the right set, because some ball are bat. What is the definite? See, for a given statement, there is a definite conclusion, right? So for a given conclusion also, there can be a definite something which can be called a statement. If some ball are bat, definitely some bats are balls. Some bats are balls. And then here, no stump is a ball means what? No ball is a stump. No ball is a stump, right? Some bat or ball. Some balls are bat implies some bats are balls. No stump is a ball. No stump is a ball means no ball is a stump, and that's exactly what given here. Some bat or ball, some bat or ball. No ball is a stump. No ball is a stump. So third one follows, right? So once we have got the right answer, we need not actually check D and E here, but looks like there's some problem with this particular set of options here. D also seems to be the right option. So let's check this. All bat or ball, no ball is a stump. Now if you actually see, there is no difference between C and D. Some bat or ball or all bat or ball will give you similar diagrams. No ball is a stump is anyway same here. Both are same, no problem. But here there's only one difference. Some bat or ball has been changed to all bat or ball. See, if all bat or ball, if all bats are ball, then some bats are ball can also be concluded. Yes or no? I mean, if you have to draw the diagram for this one, let's say all bats are balls, these are bats, all of them are balls, these are balls. No ball is a stump. No ball is a stump. Balls and stumps will not overlap each other. So what happens? Some ball are bat. Yes, if all bats are balls, then some balls are bats, and no ball is a stump. So D also is correct. D also is correct. D also is correct. Yeah. If you want to check E, let's check E. Some bat are definitely stump. See, the word definitely is redundant here. It's not required. Even if definitely is not used, when he says some bat are stump, definitely some bats are stump, right? Some bats are stump, right? There's an overlapping here. Some bats are stump. No ball is a bat. Achha, but when he says no ball is a bat, when he has very clearly said no ball is a bat, how can some ball or bat be true? So E is incorrect. We don't have to draw the diagram for this one. Sorry. He has very clearly mentioned no ball is a bat. If no ball is a bat, we cannot conclude that some balls are bat. So I think both C and D follow. Both C and D follow. Both C and D follow, right? So answer should be both C and D are correct. Both C and D are correct. Both C and D are correct. All right. Both C and D are correct. I'm sure all of you have followed this explanation here. Now, many of you have marked option C as the answer. While you are partially correct, I'll still give it to you, because the idea is during an examination, once we have found that C is giving us the right answer, we will not check for D and E, right? Whenever you have to go by options, if a particular option has given you the answer, then you need not verify D and E unless D and E are some combination of the earlier options, right? Here, clearly each option was a set of statements, right? So I've got the answer as C, I'll mark it as C and move forward, right? And definitely this question itself is not really framed properly, right? Because you cannot have two correct answers for a given question. Okay, so even if you have got C, don't panic, don't worry that, oh, I have got the wrong answer, I did not verify D. You're not supposed to verify D unless, you know, options have been given that way, or unless options are something else where you have to choose which two set of statements are correct. But that doesn't seem to be the case here. Okay, so even if you have got C, be happy, you have got the right answer. C and D both the right answer. I would appreciate those who have got both C and D, because they have got that eye to check very quickly that D also seems to be the right one. Okay, so we are done with this. If you're all clear, we can move to the next question. Should we go for the next one? Is that clear to all of you? If you're all clear with this, we can take up the next one. Yeah, followed? Okay. Yeah, all of you have followed, right? Except Prem Sagar God, who says, how is D correct? Prem Sagar, my question to you is, have you gone through the video of syllogisms? Because what I've explained to you is very basic, something very basic there. You should not be getting a doubt about how D is correct. D is also correct. Just watch this video once again, I'm sure you will understand this. Let me present the next one to all of you. Here we go. This was posted by Kundan Kumar. I don't know if his username is Kundan Kumar Star Performer or Star Performer has got copied from the discussion forum. Anyway, so Kundan Kumar has posted this. One more question on Silogs. 3 statements, 3 conclusions. You are to identify which of these conclusions follow the given statements. You have 1 minute for this. The clock starts now. Quick. One and three. One follows, 1 and 3 follows, only one follows. Different answers have come in. Okay, let's take this up. So, the question on syllogisms posted by Kundan Kumar. Statements. Some animals are flowers. Some animals are flowers. Some animals are flowers. Many flowers are birds. See, many flowers are birds is as good as some flowers are birds. All these words, many, right? Most, few, all these are equivalent to some, right? Some animals are flowers, many flowers are birds is like some flowers are birds, right? Some flowers are birds. So some flowers are birds. We are drawing the minimum overlapping diagram, right? The basic diagram, what is called the basic diagram. The minimum overlap has to be taken into account. So some animals are flowers, some flowers are birds. No animal is a bird. No animal is a bird. Okay, so it satisfies. See, some animals are flowers, some flowers are birds, and in the process we should ensure that no animal is a bird. No animal is a bird. Yes or no? These two are not touching each other. So by any chance, if you have drawn the diagram this way, let's say some animals are flowers and then some flowers are birds. So some animals are flowers is true. Some flowers are birds is also true. But in the process, you are overlapping animals with birds. He says no animal is a bird, right? No animal is a bird. So this would be treated as an incorrect diagram, right? The correct diagram is this. No animal is a bird. Animals and birds are not touching each other. Now look at the conclusion. The first one. Some flowers are not birds. Some flowers are not birds. Is it true? Some flowers are not birds. Well, if I look at the basic diagram, it is true. Some flowers are not birds. The outside flowers are not birds. But will it always be true? See, if you remember, one of the basic points that we have discussed it, if some A's are B's, does not mean that some A's are not B's. Here, the statement said some flowers are birds. Some flowers are birds. That does not mean that some flowers are not birds. Independently, if you check, we are checking the conclusions independently as of now. So when some flowers are birds, forget about the diagram. When some flowers are birds, it does not mean that some flowers are not birds. Because some flowers or birds can also be drawn in this fashion. Flowers and birds, both are shown by the same circle. This also indicates some flowers are birds. This is a possible diagram. This is a possible diagram. This is a possible diagram. Some flowers are not birds. So if I consider this possible diagram, some flowers are birds, what happens? If I consider this as a possible diagram, some flowers are birds. See, actually, this is the basic diagram. Some flowers are birds. This is how you have to draw it. But a possible way of drawing it is as follows. So if I take this as the correct diagram, what happens? Some flowers are not birds becomes false. So conclusion number 1 does not follow. 1 does not follow, right? Does not follow. Second conclusion, no flower is an animal. No flower is an animal. No flower is an animal. Is it true? He is very clearly given that some animals are flowers. If some animals are flowers, the definite conclusion is some flowers are animals. If some A's are F's, some F's are A's. That is for sure. Some F's are A's. Some A's are F's. So some F's are A's. If some F's are A's, then how can you say no F is A? This is wrong. This is incorrect. You're able to follow? No F is a is a wrong conclusion, right? Because some flowers are animals. So you cannot say no flower is an animal. The third conclusion, some animals are not flowers. Some animals are not flowers. Again, similar to the first one. Some flowers are not birds. Here it says some animals are not flowers. See, we know that some animals are flowers. If some animals are flowers, it does not mean that some animals are not flowers, because a possible way of drawing the diagram is as follows. What did he say? Some animals are flowers. I can draw animals and flowers with the same circle, represent both of them with the same circle. This also means that some animals are flowers. But if I take this as a possibility, this becomes false. Some animals are not flowers becomes false, because all the animals are flowers. This also is incorrect. This also is incorrect. You're able to follow? So conclusion 1 is false, conclusion 2 is false, conclusion 3 is also false. All three of them do not follow. Now pay attention. Pay attention to a very important point. Yeah. Independently, if you check, this is what you come at. This is what you conclude, right? But now understand that we had considered this to be a wrong diagram. This diagram was considered to be wrong in the beginning. Why was it considered to be wrong? Because of the third statement given to us. The third statement says no animal is a bird. I'll tell you the challenge here. Suppose you take this as a possible diagram. On what basis have we concluded that 1 and 3 are incorrect? On the basis of these two possible diagrams. But the point is, if I consider this as a possible diagram, look at this one, possible diagram 1. Let me see, this is possible diagram 1, this is possible diagram 2. If I take possible diagram 1 as correct, I mean actually as a possibility, let's see if it is actually possible or not. What happens? He said some flowers are birds. I have drawn it in this way. The other statements are about some animals are flowers. Some animals are flowers. Animals should be drawn in this way because some animals are flowers. But then look at the third conclusion. No animal is a bird. That becomes false here because some animals are becoming birds. The point is, if you make flowers and birds equal, if flowers and birds both are represented with the same circle, with the same set, then when you say some animals are flowers, those animals which are flowers are also birds. But the third statement says no animal is a bird. Is it satisfied in this possible diagram? No. No animal is a bird is not satisfied in this diagram because some animals are becoming birds. Which means this cannot be taken as a possible diagram. Which means you cannot consider flowers and birds to be the same set. Flowers and birds can never be overlapping completely each other. There should definitely be some flowers which are not birds. There should be at least one flower which is not bird, and that flower can be overlapped with animals without violating any of the conditions. So since this possible diagram 1 is wrong, the idea of taking flowers and birds equal is also wrong. If flowers and birds cannot be equal, then some flowers are not birds becomes a true conclusion. Are you able to follow? Actually, conclusion number 1 is true. 1 follows. In a similar way, conclusion 3 also follows. The point is, the moment you say some animals are flowers is represented as this. All animals are flowers. Then some flowers are birds. So these should be birds. Some flowers are birds. But in the process, the birds are overlapping with animals or not. The third statement says no animal is a bird. I cannot go against the statements. It clearly said no animal is a bird. Here, some animals are becoming birds. Some animals are becoming birds. Hence, this cannot be taken as a possible diagram. Because this violates the statement. Which statement? No animal is a bird. This also violates the same statement. No animal is a bird. Why is it violating the statement? Because I am considering all animals to be equal to all flowers. All the animals are same as all flowers. Both of them are represented by the same set, which means this cannot be considered. If this cannot be taken as true, then this conclusion becomes correct. Some animals are not flowers. Some animals are not flowers is correct. Some animals will not be flowers. Remember, the set of statements are tricky here. Some animals are flowers, some flowers are birds. The third statement is got both the components which are already available in the first two statements. If the third statement had a new element, then checking independently would have been fine. But the third statement here has got both the components, animals and birds, which are already a part of the first and the second statements. Remember, while drawing the basic diagram, we found that the third statement was not drawn at all. Only the first and the second statement were drawn. Third one automatically got satisfied in the basic diagram. Yeah. So going by all this, you now have to conclude that only 1 and 3 follow. Some flowers are not birds and some animals are not flowers. Because no animal is a bird. This is a very, very important statement given here. You getting it? So answer should be only 1 and 3 follow. 2 is definitely wrong. No flower is an animal is definitely wrong, because he is very clearly given no flower is an animal. Why was this wrong? No flower is an animal. Yeah, because some animals are flowers. He has very clearly given some animals are flowers. If some animals are flowers, obviously some flowers are animals. Then how can you say no flower is an animal? Second one is wrong, but the first and third one are correct. That some flowers are not birds and some animals are not flowers. See, these flowers, outside flowers are not birds. These cannot be birds. And these animals cannot be flowers. Some animals are not flowers. Okay? Okay, so a little tricky question, but yeah, the answer is only 1 and 3 follow, or both 1 and 3 follow. I hope all of you have understood this. Yeah. So 1 and 3 follows is the correct solution. Atish, Manish, all these guys have got the right answer. Ramalakshmi has got a question. Here many refers to what? Many refers to some. Many is not all. Many is some. Many, most, 99%, 99.99%, 2%, 0.6%, all these are some. Right? Remember, there are only 3 things. 0, all, anything between 0 and all is some. So even if it says many or most of them, even then it means some. Okay? Clear? Should we go for the next one now? Yeah? Some more syllogisms. Okay, here we go. The next question on your screens now. Again, posted by Kundan Kumar. 2 statements and 2 conclusions. You have 1 minute for this. The clock starts now. Try this one. Simple, 2 statements and 2 conclusions. All shells are racks. All racks are not replaceable. Some shells are not replaceable, or some replaceable are racks. Quick. Don't take it to be a very silly one. You have to be careful. Even if there are just 2 statements and 2 conclusions, be careful when you are solving it. Okay? Quick. Got it? Okay, here we go. So the question here has got two statements and two conclusions, right? What do we have to do? The usual stuff. Find out which of these conclusions logically follow the given statements. Now look at the statements. All shells are racks. All shells are racks. So shells and racks. All the shells are racks. All racks are not replaceable. So let me say racks are RK and replaceable is RP. So all shells are racks. I'm drawing the basic diagram, right? The basic diagram. All shells are racks. All racks are not replaceable. All racks are not. See, this is called a, this is like a universal negative statement, right? All racks, all A's are not B's. This is a universal negative statement. What is a particular negative statement? We have discussed about particular negative in our videos, right? Some A's are not B's. Some A's are not B's. Particular negative. Right? All A's are not B's. Universal. All. I mean all, right? This refers to universal. Some is particular. So how do you draw the diagram for this one? All A's are not B's. A's and B should not be touching each other. I mean, it's like this. There should be no overlapping between A and B, right? How do you draw the second one? Particular negative one. Some A's are not B's. A here and B here. These outside A's are not B's, right? Here all A's are not B's. All the A's are not B's. All these are not B's. So what is the definite conclusion? All A's are not B's. All A's are not B's means all B's are not A's. Or no B is A. Or no A is B. Yeah. We can also say some A's are not B's and some B's are not A's. You're getting to understand this. All A's are not B's. Definite conclusion is all B's are not A's. Or no B is A. Or no A is B. Right? Or some B's are not A's. Or some A's are not B's. All these are correct conclusions for the given statements. Okay. So all shells are racks. Easy to draw. All racks are not replaceable. All racks are not replaceable. All racks are not. Racks and replaceable will not touch each other. Racks and replaceable will not touch each other. By which shells and replaceable also will not touch each other. Because racks and shells are equal. Yes or no? I mean shells is equal to racks basically. All shells are racks means what? Shells is equal to racks. S is equal to rack. Remember, rack is not equal to S. But S is equal to rack. All shells are racks. All shells are racks. In fact, I think I should not be drawing this diagram. I'm sorry. All shells are racks, right? All shells are racks. I'm sorry about this. I should be. What I consider is a possibility. I should draw the basic diagram, right? All shells are racks. Shells here and racks here. All shells are racks. Sorry about this. Yeah. All shells are racks. All shells are racks. So all the shells are racks, but not all the racks are shells. So all shells are racks. All racks are not replaceable. Means no rack is a replaceable basically. Yeah. Universal negative. Now look at the conclusions. Some shells are not replaceable. Some shells are not replaceable. True or false? True. See, replaceable cannot touch racks. How will replaceable touch shells? Or how will shells touch replaceable? Not possible. So some shells are not replaceable is true. In fact, all the shells are not replaceable. Strictly speaking, all the shells are not replaceable, but we can also say some shells are not replaceable. Some replaceable are racks. Some replaceable are racks. No. Not possible at all. All racks are not replaceable. So no replaceable is a rack. If no replaceable is a rack, how can you say some replaceable racks? This is incorrect. So conclusion number 1 follows, conclusion 2 does not follow, only 1 follows. You're getting it? Some shells are not replaceable. Some shells are not replaceable. True. Some shells are not replaceable. So remember, don't get confused that all shells are not replaceable. When all shells are not replaceable, I can also say some shells are not replaceable. I can pick up some of these shells and say these shells are not replaceable. Try and understand. Many of you who have marked 1 as wrong, conclusion 1 as wrong, are assuming that the answer is all shells are not replaceable. And that is why some shells are not replaceable is incorrect. Remember, if all shells are not replaceable, I can say some of these shells, I can say these shells are not replaceable. Some of these shells, these are some of the shells, right? These are not replaceable. It's like that popular, very easy to understand example that I gave you last time, right? I have 1000 rupees. You have asked me, do you have 200 rupees? What should be my answer? Think about it in that direction. Very simple explanation, right? I've got 1000 rupees with me. You come to me and ask, do you have 200 rupees? Should I say yes or no? According to you, I should say no. Why should I say no? Because I have 1000 rupees and you are asking me for 200 rupees. 200 is not equal to 1000. But the fact is, 200 is a part of 1000. I can say yes, I have 200 rupees. Some is a part of all. While all the shells are not replaceable, I can still say some shells are not replaceable. You're able to follow? Keep that in. This is what is deductive reasoning, right? I mean, you know, when you talk syllogistically, you actually mean this, right? You have to, this is what is logic. I've got 1000, you have asked me for 200. Should I say yes or no? I should say, if you say first conclusion is wrong here, some shells are not replaceable is wrong here, you are trying to say that my answer should be no, I don't have 200 rupees. But logically, I have 200 rupees. 200 is a part of 1000. I can say yes, I have 200 rupees. Yeah? There are 100 students in a classroom. All the 100 students have cleared the bank exam. My friend comes and asks me, did some of your students clear the bank exam? Should I say no? I should say yes. Some of my students have cleared. All of them have cleared is a different story, but some have cleared, right? If I say no to him, what does it mean? No. Some of my students have not cleared the exam. Is that true? All the students have cleared. How can I say some of the students have not cleared? Think it that way, right? I mean, I've explained this multiple times in our earlier sessions as well, even in the videos. You have to think in all possible directions before you jump to a conclusion. Okay, so the answer should be only 1 follows. Some shells are not replaceable. If this is clear to all of you, I can move to the next one. Clear? I had spent a lot more time than required on this particular question because many of you said none is the answer, none follows, none follows. But the actual answer is only 1 follows. Clear? Yeah. Okay, so I've got some confirmation here. I can jump to the next one. So let's solve a couple of more questions on these type of statements, right? All A's are not B's type of statements, so that you are thorough with this concept, right? Universal negative statement. So presenting the next question to you all now, again by Kundan Kumar on syllogisms. Here we go. Simple one again, 2 statements and 2 conclusions. All calendars are charts, all charts are not papers. Some papers are not calendars, some charts are not calendars. 1 minute is what you have. The clock is ticking. Correct? Both follows. Kirti Vikas says 1 follows. Ramalakshmi, Divya and S. Mukherjee says 1 and 2 follows. Both follows. It's 12:35. We have another 25 minutes to go. I think we'll solve these couple of questions on syllogism and then move to a arrangement question, right? We haven't done any arrangement in the session today. Let's take up one arrangement as well. All right, the time is up. Let's discuss the solution now. Here we go. So statements: all calendars are charts, all charts are not papers. How do you draw this? All calendars are charts. Calendars, all the calendars are charts. All the calendars are charts, right? All charts are not papers. All charts are not papers means charts and papers will not overlap, right? All calendars are charts. All charts are not papers, right? Universal negative statement. We have discussed this a few minutes ago. All charts are not papers. So all the charts are not papers. Look at the conclusions. Some papers are not calendars. Some papers are not calendars. True. In fact, all the papers are not calendars. Papers and calendars cannot overlap at all because calendars are completely guarded by charts. Calendars are fully guarded by charts. Calendars cannot go outside charts. If calendars cannot go outside charts, papers and calendars cannot touch each other. So actually, all papers are not calendars, or no paper is a calendar, but some papers are not calendars also can be taken as correct. I can say these papers are not calendars, or these papers are not calendars. Some of these papers are not calendars, right? Next conclusion: some charts are not calendars. Some charts are not calendars. True. Some charts are not. If you look at this is the basic diagram. If you look at the basic diagram, some charts are not calendars. These outside charts are not calendars. But will it always be true? See, the first conclusion will always be true because papers can never touch calendars. Paper can never touch calendars. It cannot go inside charts, so it cannot touch calendars. Second conclusion has satisfied the basic diagram. Outside charts are not calendars, right? Some charts are not calendars, outside charts are not calendars. But will it always be true? No. It will not be true always. Why? See, all calendars are charts. There is another way of drawing it. All calendars are charts can also be drawn in this way, right? Let me draw the possible diagram. All calendars are charts. I can say calendars and charts both are the same circle. All the calendars are charts. And all charts are not papers. All charts are not papers. All charts are not papers. This is a possible way of drawing the diagram. All calendars are charts and all charts are not papers. Then what happens? Some charts are not calendars. Tell me which chart is not calendar? All the charts are calendars here. All the charts are calendars. So the point is, second conclusion clears the basic diagram. It satisfies the basic diagram, but it fails in the possible diagram. Hence, it is wrong. Remember, a conclusion, a definite conclusion is true if and only if it satisfies all the diagrams. If and only if it satisfies all the diagrams. Here it satisfies the basic diagram, but not the possible diagram. First conclusion satisfies both the basic diagram as well as the possible diagram. You see, even the possible diagram it satisfies. Some papers are not calendars. Yes, these papers are not calendars. Papers and calendars will never overlap. So only one follows. Only one follows. Should be the answer. Clear? Only one follows. Quickly confirm on this one so that we can move to the next question. Divya has asked a question. Can anyone please explain at least and at most are possibilities or conclusions? Divya, we have discussed this like some 179 times so far about at least and at most. What you can do is refer to our advanced example videos. At least, some and some both are exactly the same. It has got nothing to do with possibility or a possible type of conclusion or definite type of conclusion. At least some or some means the same, right? Should we move to the next one? Yeah, okay. Let's take one more question on syllogs and then we will jump to some arrangement one. Here we go. All stars are black holes, all stars are not planets, some stars are luminescent. Conclusions are some planets are not luminescent, all planets are luminescent. Got it? Either one or two. Okay, R.R.K. Sharma has got either one or two. Divya says only one follows. Ramalakshmi and Ankita Sharma has also got only one follows. Kirti Vikas says only one follows. So confusion here again, right? Your answers are all not in sync. Let me wait for a few more responses. Quick. All right, so time is up. Let's try this out now. Here we go. Statements. All stars are black holes. All stars are not planets. Some stars are luminescent. So draw the diagram for this one. All stars are black holes. All stars are black holes. So let's say stars here. All of these stars are black holes. All the stars are black holes. Okay. All stars are not planets. All stars are not planets means what? Planets and stars will not touch each other, right? The universal negative statement that we talked about. So all stars are black holes. All stars are not planets. Some stars are luminescent. Some stars are luminescent. So we can say this is luminescent, right? Some stars. You see, these stars are luminescent. Some stars are luminescent. So this is the basic diagram. This is the basic diagram for the given set of statements. All stars are black holes. All stars are not planets. Some stars are luminescent. Now look at the conclusion. The first conclusion. Some planets are not luminescent. Some planets are not luminescent. If I look at the basic diagram, yes, some planets are not luminescent. Actually, all the planets are not luminescent, but I can say, yeah, some of these planets are not luminescent. So this conclusion clears the basic diagram. The first conclusion follows the basic diagram. But just because it follows the basic diagram, can you mark it as true? No. You have to check all the possible diagrams. So let me draw a possible diagram for this one. Let me draw a possible diagram for the given set of statements. Right? All stars are black holes. I mean, I think we'll only have to treat planets differently, because the conclusions are only about planets and luminescent. If you see, in fact, the second conclusion is also about planets and luminescent. So let's only try to draw possible diagrams in such a way that we are interfering with planets and luminescents. Whether we change stars and black holes doesn't really matter there, right? So all stars are black holes, right? All stars are not planets. All stars are not planets. So all stars are not planets, and some stars are luminescent. Some stars are luminescent. I can draw some stars are luminescent in this fashion. This is luminescent. Yeah. So see, some stars are luminescent. Did we violate any of the statements? No. Both in the possible and the basic diagram, we have not violated any of the statements, right? Look at the statements again. All stars are black holes. All the stars are black holes. All stars are not planets. All the stars are not planets. Some stars are luminescent. Some stars are luminescent. Now, look at the conclusion. Let's look at conclusion number one. In fact, both of these are forming a complementary pair, right? Some planets are not luminescent. All planets are luminescent. This is like a complementary pair, right? The second complementary pair. There are two complementary pairs. What are the complementary pairs? All A's are B's. Some A's are not B's. Another complementary pair is some A's are B's, no A is B. So this is like the one of the complementary pairs. All A's are B's and some A's are not B's is a complementary pair. Yeah. So since this is a complementary pair, we have to treat it properly. If you want to learn more about complementary pairs, please refer to our videos on syllogism, complementary pair, right? One of the complementary pairs. All A's are B's, some A's are not B's. So what we'll do is we'll check both the conclusions in basic as well as possible diagram. So conclusion number one, some planets are not luminescent. Some planets are not luminescent. Yes, follows the basic diagram. But it fails in the second possible diagram. You see, it fails in the possible diagram. Some planets are not luminescent. Which planets are not luminescent? All the planets have become luminescent. If all the planets have become luminescent, some planets are not luminescent becomes false. So the point is, I mean, if you have to draw, if you have to explain this to you, like how complementary pairs behave. Let's say this is a basic diagram B, and this is a possible diagram P. Conclusion number one: some planets are not luminescent. Some planets are not luminescent. Yes, it satisfies the basic diagram, but it fails in the possible diagram. Some planets are not luminescent. Which planets are not luminescent? All the planets are luminescent. If all the planets are luminescent, how can you say some planets are not luminescent? Look at second conclusion. All planets are luminescent. All planets are luminescent. It fails the basic diagram. All planets are luminescent.
it fails in the basic diagram. But all planets are luminescent, clears the possible diagram. So the point is, if one conclusion is true, the other one is false. You see, first one is true, second one is false in the basic diagram. In the possible diagram, the first one is false, but the second one is true. Yeah. So this is behaving like a complementary pair, and hence your answer should be either one or two follows. Either one or two follows. This is an either or case, complementary pair case. Yeah. So the final answer should be either one or two follows. Either one or two follows. Either one or two follows. Okay. Independently, both of them are wrong. Some planets are not luminescent is wrong. All planets are luminescent is also wrong. But when you go for the combination, you find either one or two is correct. So either one or two follows should be the right answer. Trust you have understood this. Okay, Tejasvi has got a confusion here. Tejasvi says all stars are not planets, then possible diagram cannot be considered as there is a connection between star and planet. No. If you look at the possible diagram that I have drawn, there is no connection between star and planet. Here also stars and planets are different. They are disjoint. Yeah. Arpita Majumdar has got a question. If all A's are not B's, then no A is B or no B is A? Then both are correct. No A is B and no B is A. If no A is B, obviously no B is A. Ankita Sharma had mentioned that this is not either or case. This is an either or case, Ankita. Some A's are not B's, all A's are B's. It's an either or case. It need not always be true, but it looks like an either or case, right? You should never blindly mark the answer. Some people have this idea, a shortcut, that whenever you find a complementary pair in the conclusions, mark it as either or. It's incorrect. That's not the way you do it. Just because it is looking like a complementary pair does not mean that it is always either or. Sometimes what happens is only one is always correct and the other one is always false. That is why you have to verify. Like in this case, what did you find? When one is correct, the second one is false. In some cases, the second is correct, the first one is false. Only then you can say that it's a complementary pair. Yeah. I think we are done with this. We can take up one question on maybe arrangements and then call it a day. Yeah. Let's take up something on arrangement then. I have questions lined up here. We'll just solve one more and then close it. Okay, so this was posted by Abhi Tripathi. It is on arrangement of 10 persons in 12 seats distributed in 2 rows, where one row is facing north, the other row is facing south. You've understood what I am talking about, right? We have solved such questions in our videos as well and in our earlier doubts clarification sessions. Let's take one more. It's a complex arrangement. It's a complex linear arrangement, and the question is on your screens now. Try this out. He said there are 12 seats. Look at the question. Study the following information to answer the given questions. There are 12 seats in 2 parallel rows having 5 people each. There's an equal distance between adjacent persons. In row 1, A, B, C, D and E facing south, and in row 2 we have U, V, W, X, Y, X and Y who are facing north. One seat is vacant in each row. Therefore, in the given seating arrangement, each member seated in a row faces another member of the other row. All of them like different colors like black, white, cyan, indigo, pink, beige, blue, brown, red and green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically 10 persons, 10 colors, 12 seats. One seat is vacant in each row. And here's the data. I'll leave you with this for at least 5 minutes. Your clock has started ticking. Let's see how many of you get the right solution. Try this out. Don't give up. I mean, our strategy in the exam would be to skip these questions and try it when time permits. But here, when you're practicing, you should give it a sincere try. So your clock starts now. I hope all of you are trying it out. Please keep posting it in the chat that you are still trying it, and don't give up, right? I mean, I just want to make sure that you guys are trying it and not sitting idle. Yeah, good to see your responses in the chat. Please try it out sincerely. Looks like a difficult one, not so easy to crack. You may get multiple possibilities. Try out. The start is very important. You have to pick up the right statement, the most efficient statement, so that it becomes easier for you to check the possibilities, right? So your starting point is very, very important. I hope all of you are progressing with the solution. Looks like Ramalakshmi has got something about row 1, waiting for more responses to come in. If you look at the statements intelligently, I'm sure you'll be able to crack it. Let's wait for a couple of more minutes. Time is already up, more than 5 minutes now. But since no one has got the solution, I am giving you more time. Okay, 2 more minutes and then we'll take it up. Looks like Naveen Kumar, Avanti, Kiran and Ramalakshmi. These 4 have got something about row 1, waiting for more responses to come in. Nobody has marked anything about row 2 yet. So just check it out quickly. Okay, 30 more seconds and then we'll take it up. Looks like nobody has got it. If anyone has done it completely, please mention that in the chat. We have just 30 seconds before we start discussing the solution. Should we start? Has anyone got the solution? That's the question. Alright guys, I think given you enough time to try this, more than 10 minutes now, and I'm sure the fact that not many of you have got the solution, so that it's a complex one, right? A complex linear arrangement. So what we're going to discuss now is a complex linear arrangement where we have to arrange 10 persons in 2 rows of 5 persons each. But interestingly, each row has got 6 seats. So there are basically 12 seats across 2 rows, in 2 rows, between 2 rows. In each row, 1 seat is vacant and the other 5 seats are filled up or occupied by 5 persons. So 10 persons have to be arranged in 2 different rows having 6 seats each. Each row has 1 seat vacant. One row, the persons in one row are facing south and the persons in the other row are facing north. And it's not just this, not just the arrangement of 10 persons, but also we have to assign a color to each of these persons, right? Each of these 10 persons have got their own favorite color. So with all this complexities involved, what we are going to take up now is a complex linear arrangement, and I'm sure you would find such type of questions in bank exams, right? Bank and other competitive exams. While the ideal solution always is to skip these questions, try it out only towards the end, right, when you are done with the other part of the paper. But from the practice point of view, it's important to solve more and more such questions so that you can think of all the possibilities and do it really quick if at all you have to do it in the exam. Okay, so let me present the question to you all and then discuss the solution. Here we go. So here's the question. Let me read it out first for all of you and then we will take up the solution. See what it says. Study the following information to answer the given questions. This was posted by your friend Abhi Tripathi in our discussion forum of reasoning section. So he says there are 12 seats in 2 parallel rows having 5 people each. There's an equal distance between adjacent persons. In row 1, we have A, B, C, D and E facing south, and in row 2, we have U, V, W, X and Y who are facing north. Now there's an importance of the facing south and facing north here, right? When persons are facing south, left should be taken towards right and right has to be taken towards left. When persons are facing north, left should be taken towards left and right has to be taken towards right. We have discussed these basics in our linear arrangements video, if at all you are not clear with it, right? Now 1 seat is vacant in each row. So therefore, in the given seating arrangement, each member seated in a row faces another member of the other row. All of them like different colors like black, white, cyan, indigo, pink, beige, blue, brown, red and green. So 10 colors, 10 persons, A, B, C, D, E, U, V, W, X and Y, 2 rows, and each row has got 6 seats, right? 1 seat is vacant in each row. And here are all the clues given to you, like Y likes neither brown nor red, W and V are not immediate neighbors, D is immediate neighbor of A and C, one of the vacant seats is 4 to the right of E, C does not like black color, there is only 1 seat between the persons like green and cyan and so on. Okay, remember when you're solving such questions, it's very important. See, if it is a circular arrangement, there is an advantage. In a circular arrangement, since it is a closed loop, we can start from wherever we want, right? When you're solving a question on circular arrangement of 12 persons or 10 persons or 8 persons or 40 persons, it's a closed loop. So there's no number 1, number 2, number 3 positions there. You can start from wherever you want. I mean, at least that starting advantage we have, which is ruled out in case of linear arrangement. Because when you talk about a linear arrangement where there are 5 seats or 6 seats in each row, there is a definite numbering done there, right? I mean, this is the first seat, I know, then the second seat, third, fourth, fifth and sixth, right? In a circular arrangement, you can start from wherever you want. You cannot start from wherever you want in a linear arrangement. You should know the definite position. I can put D in the first seat only if I know that he belongs to that seat. But in a circular arrangement, I can put D wherever I want and I can arrange the other persons relatively. That's not possible in a linear arrangement. So that's one challenge we have when it comes to linear arrangement. And the other point you have to remember here is that south and north, right? What is the importance of these directions? When a person is facing north, left should be taken towards left and right has to be taken towards right. When a person is facing south, his left should be taken towards our right on paper and right should be taken towards our left on paper, right? I mean, you should go through our videos on linear arrangement to understand why this happens and why do we do it this way. Okay, so keeping all these points in mind, let's try and solve this question now. Okay, here we go. So here's the question. I think there's only one question available who like green color. See, answering the 5 questions or 8 questions asked along with this is a very simple task. All we have to do carefully is the arrangement, right? So let's start doing the arrangement now. Okay, so there are 12 seats in 2 parallel rows having 5 people each. Anyway, the basics are all known to us, right? 12 seats, 2 parallel rows, 5 people in each row, right? And A, B, C, D, E are all facing south, U, V, W, X, Y are facing north, right? Row 1 and row 2, row 1 and row 2. 1 seat is vacant in each row, right? Then there are different colors. There are different colors from black, white, cyan, indigo, pink, beige, blue, brown, red and green. Okay. Now, what we would do here is, see, the important point, like I've already mentioned, north. A person is facing north. This is his right and this is the left. Keep this in mind. A person is facing south. This is the left and here's the right. Right? Keep this in mind. Keep this in mind when you're doing the arrangement. I'll clear it up because I have very limited space and I'll need more space to, you know, do the rough work and, you know, consider all the possibilities. So I hope all of you have understood that. Now, what we would do here is, see, it's important to find out the right starting point. I have already told you what's the limitation with linear arrangement, right? I mean, if I start with Y likes neither brown nor red, it's complex. I mean, if it does not like brown or red, there are 8 more possibilities. I can't be taking all those 8 possibilities. If W and V are not immediate neighbors, this is not the right starting point. I mean, W and V are not immediate neighbors means what? They cannot sit together, but there can be 1 person between them, 2 persons between them, 3 persons between them, 4 persons between them. Multiple possibilities are there, right? So starting point is very important. However, understand the arrangement would look something like this. He says in row 1 we have A, B, C, D, E facing south. So this is like, let's say row number 1, 6 seats, 1, 2, 3, 4, 5, 6. Row 2 we will have 6 seats again, 1, 2, 3, 4, 5, 6. Each seat faces opposite, 1 seat in the opposite row, right? Who are the candidates in row 1? A, B, C, D, E. A, B, C, D, E. In row 1, all of them are facing south. Who are the candidates in row 2? U, V, W, X, Y. All of them are facing north. Okay, in some fashion there, and each row there is a vacant seat. So we'll represent the vacant seat with a dot. In each row there is a vacant seat, right? So we'll represent that with 0. Let's say 0 vacant seat. 0 indicates a vacant seat. Okay, wherever it is, in each row we have a vacant seat. So this is what we need to keep in mind. Now let's find out the right starting point. D is immediate neighbor of A and C. Now what do you mean by this? D is an immediate neighbor of A and C. See, we know that D, A and C, all 3 of them will be in the top row, in the first row. All of them will be facing south. Now since D is an immediate neighbor of A and C, it means D will be between A and C. D is going to be between A and C. D is going to be between A and C. So let me write all these clues in some pictorial representation, right? I mean, one easy way to solve arrangement based questions, linear arrangement based questions, is to represent the statements pictorially. So D is a immediate neighbor. The neighbor spelling is wrong, by the way. Let's ignore that. But D is an immediate neighbor of A and C. So what are the possibilities? A, D, C or C, D, A. See, these are the only 2 ways where D is an immediate neighbor of A and C, right? D is between A and C. So you have to keep this in mind when you're doing the arrangement. Okay. Then one of the seats is, one of the vacant seats is 4th. Now, this is not the best starting point in my view. D is an immediate neighbor of A and C is not the best starting point, because where will these 3 persons come? They can come in 1st, 2nd, 3rd seats. They can come in 2nd, 3rd, 4th seats. They can come in 3rd, 4th, 5th seats. They can come in 4th, 5th, 6th seats. Again, there are 2 possibilities for each triplet. So that's not the best way to start. Look at this. One of the vacant seats is 4th to the right of E. Now this to some extent looks like a good starting point. One of the vacant seats is 4th to the right of E. Remember, E is in the top row. E is facing south. Right of E would mean towards our left. One of the vacant seats is 4 to the right of E. See, there are only 2 possibilities. For this statement, there are only 2 possibilities. One of the vacant seats is 4 to the right of E, right? So if E comes in this position, let's say, E comes in this position, 1, 2, 3, 4, vacant seats come here. Or E can come in this position. See, if E comes here, vacant seat will come 1, 2, 3, 4, vacant seat will come here. E comes in this position, vacant seat comes 1, 2, 3, 4 here. These are the only 2 ways in which this statement can be used. Now, since there are only 2 possibilities, let me consider those 2 possibilities. Okay. So I'll take those 2 possibilities here. It's like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? The other possibility is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I mean, it may look a little clumsy because I'm too short on space here, but understand. So let's say E comes here. See what he says, one of the vacancies is 4th to the right of E. Right of E is towards our left because E is facing south. 1, 2, 3, 4. The vacant seat is here. Vacant seat is here for the top row. What the other possibility? E comes in this position. 1, 2, 3, 4. The vacant seat comes here. These are the only 2 possibilities. So this is like case 1. This is case 1, let's say, and this is case 2. Okay. Now what we will do is any statement that we choose, we'll try to mark in both case 1 and case 2. Okay. Then C does not like black color. Now this is not very useful statement, right? There's only one seat between the persons who like green and cyan. So only one seat between green and cyan. Remember that, right? I mean, it's like a clue. Green and cyan will have only one seat between them. Okay. But remember, these two can be interchanged. It can be green dash cyan or cyan dash green. Okay. V likes black or blue. All these will be used at a later stage, useful at a later stage. The one who likes brown is sitting fourth. Okay, I think the other thing that can be used is this point, right? ADC, CDA. See, ADC, CDA. See, understand, we know that ADC are all sitting together and all of them will be in the top row. Before I go to the next statements, let's just use this itself. ADC or CDA. ADC will sit together because D is an immediate neighbor of A and C. And all of them should come in the top row, right? In row number 1. So if you see, the only possibility for ADC is these 3 seats. ADC or CDA. ADC or CDA. Yes or no? In case 1, ADC should come here or CDA should come here. In case 2, ADC or CDA should come here. There's no other way out, right? There are no other 3 consecutive seats available. But again, the challenge is it ADC or CDA? That is not sure. It can be ADC or CDA. However, D will always come in this position. That is for sure. Here also ADC or CDA. D will definitely come here. Now between this, it can be A, C or CA. Here also it can be A, C or CA. So A and C will come in these 2 positions. And that also shows that the other, see, E is fixed. E is fixed. D is also fixed. A and C will come on those 2 positions, A, C or CA. The only left out person is B. B has to come here in case 1. Yes, sorry. B has to come here in case 1. In case 2, the only seat left out for B is the last position. So B comes here. B comes here. So B's position is also fixed. B is also fixed. Now A and C will take these 2 respectively. Okay. Right. So we'll not fix A and C yet, right? We don't know anything about it. There's only one seat between green and cyan. Yeah, it has to come this way. V likes black or blue. Okay. The one who likes brown is sitting 4th to the left of you. The one who likes brown is sitting 4 to the left of you. See, remember, U is gonna come in the bottom row. And left, see, bottom row guys are facing north. So left should be taken towards our left. So brown is 4 to the left of you. So again, U can come here. If U comes here, brown is 4 to the left of you. 1st, 2nd, 3rd, 4th, brown will come here. Or if U comes here, 1st, 2nd, 3rd, 4th, brown will come here. So again, there are 2 possibilities for this statement also. Brown is 4th to the left of you. Brown is 4th to the left of you. Already we have got 2 possibilities. Then there are 2 possibilities for each one. So overall it will become 2 into 2, 4 possibilities. You understand? If I take U here, brown comes here. If I take U here, brown comes here. So 2 possibilities for case 1. 1A and 1B. Similarly, 2A and 2B. U comes here, brown would come here. If U comes here, then brown would come here. So 1A, 1B, 2A, 2B. 4 possibilities would be there. But I'm not interested in trying out 4 immediately. Let's jump to the other statements and see if something can be eliminated. If one of these 2 cases can be eliminated, then it will be easy for us. Next point says B and E are not immediate neighbors. B and E are not immediate. B and E are not immediate. Okay. B and E are not immediate neighbors. Case 2 is ruled out. Because in case 2, what did we get? What we have got in case 2 is that B and E are immediate neighbors. You see? The statement very clearly says B and E are not immediate neighbors. So this can be eliminated. Case 2 is eliminated. Only case 1 is correct. Again, in case 1, you know there are 2 possibilities. It can be A, C or CA. A, C or CA. Right? Or maybe you can take U and E. Instead of worrying about A and C, I think A and C filling will be easier at a later stage. What we can do is I'll duplicate case 1. I'll say this is 1A, right? Let's take 1B now. What's 1B? Let me just redraw it again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. This is B. Right? This is B. Then the vacant seat. Then either A or C will come here. D. C or A will come here and E. I am branding this as 1B. This is case 1B. This is case 1A. Right? 1B and 1A. Right? Now we will go with this point. What is that point? Brown wala point. The one who likes brown is sitting 4 to the left of you. So let's say U comes here. See, both are same. Case 1A and 1B are exactly the same till now. The only difference is 2 different positions of U. Brown is 4th to the left of you. 1st, 2nd, 3rd, 4th. This is brown. Right? If U is here, first, second, third, fourth, this is brown. Okay. So 1A and 1B. Let's try. The one who likes cyan is sitting diagonally opposite to the person who likes indigo. This is again not very useful. There are only 2 persons between those who like pink and white. There are only 2 persons between those who like pink and white. Either A or B likes pink. Okay. D likes beige or brown. Okay, look at this. I think this point is important. D likes either beige or brown. See, we have already got brown for this position, right? In case 1A, we have got brown here. In case 1B, we have got brown here. He says D likes either beige or brown. But D is seated here and it is not brown. You see, brown and D are different. So we can now conclude that D actually likes beige and not brown, because brown has been blocked for other seat, some other seat, right? Some other seat. So we can now say that D likes beige. Yeah. So let me write that also. D likes beige, right? 1A is correct or 1B is correct, we'll figure out later, but D likes beige. Now go to the, there were these points, right? He says there are only 2 persons between pink and white. There are only 2 persons between pink and white. Either A or B likes pink. See, both are for pink, right? So let's try and use this. Either A or B likes pink. There are only 2 persons between pink and white. Either A or B likes pink. Let's assume B likes pink. See what happens. If you assume B likes pink, pink comes here. In both the cases, there should be 2 persons between pink and white. So pink dash dash white, this should be white, but this is already beige. Similarly, in case 2 also, if you say B likes pink, pink is here, there should be 2 persons between pink and white. So pink dash dash white, but can this be white? No, this is already beige, which means B cannot like pink. You're able to follow. If you give pink to B, then D should be white, but D is already beige, has been concluded. So it is not B who likes pink. B does not like pink. It is A who likes pink. Right? A likes pink. Yes or no? A likes pink. We can now conclude that A likes pink. B does not like pink. Where is A's position? Remember, A can either come here or here. A can come here or here. These are the 2 positions for A. Yes or no? These 2 dots that we have put are the positions for A. A can come in any of those 2 positions. Can we do something about it? Suppose you take A in this position. Try and understand. If you take A in this position, we know that there are, and wherever A comes, A will like pink. Remember, A and pink both are equal now. We now have understood that A likes pink, right? If you take A in this position, what happens? There should be 2 persons between pink and white. So if A comes here, dash dash, this should be white. But this is a vacant seat, 0, right? 0 is a vacant seat. So A cannot come here. Are you able to follow? If I take A in this position, this will be pink color, A with pink. There are 2 persons between pink and white. So dash dash, white has to come here, but this is a vacant seat, which means A cannot come here. A has to come here. Similarly, in the second case also, A cannot come here, because if you take A in this position with pink color, dash dash, this should be white, but vacant seat, right? Vacant seat means it will not have any color. So A cannot come here. A has to come here. And if A is here, then C has to come here. Here also C has to come here. A likes pink. Wherever A, it's pink. Wherever it's A, it's pink. Yes or no? And then if pink is fixed, then white is also fixed. If this is pink, then what is white? E should be white, because there are 2 persons between pink and white. So E is white. Here also E is white. Okay, a little clumsy, getting a little clumsy, but I can't help it. I mean, yeah. Okay, let's try the other points now. So I think with respect to first row, the arrangement is done. B, O, A, D, C, E. B, O, A, D, C, E. A likes pink, D likes beige, E likes white. Everything is correct so far. The only difference in 1A and 1B is the positions of U and brown. U and brown. Okay, let's use other points. The one who likes red is sitting opposite to A. Red is opposite to A. Okay, A is fixed, so red can also be fixed. A is fixed, red is opposite to A. Red comes here. Red comes here, right? The person sitting opposite to the one who likes white is also sitting immediately next to a vacant seat. Okay, this is a useful point. The person sitting opposite to the one who likes white. See, who is opposite to the one who likes white? This position. In case 1A it is you. In 1B it is this person, whoever comes here. So the one who is sitting opposite to white is also sitting next to a vacant seat. Whoever is opposite to white, whoever is opposite to white is also sitting next to a vacant seat. Now if you see, opposite to white in 1A, is U. He's sitting next to a vacant seat, which means this is a vacant seat. U is sitting next to a vacant seat. So this should be vacant seat, 0. In case 1B, who's sitting opposite to white? This person, whoever comes here. And that person should be immediately next to a vacant seat. But here we don't have a vacant seat, we have U. And this side anyway, there is no seat available at all. You're able to follow? The one who's opposite to white is this person, whoever comes here. This person should be immediately next to a vacant seat. But is this a vacant seat? No. This has been occupied by U, which means 1B is wrong. Yes or no? I can now conclude that 1B is wrong. This is wrong. 1A has to be correct. 1A has to be correct. Right? So now we have only one case, 1A. We have to work on that. I hope there are no more possibilities because I don't have any space here left out. Yeah. So let's look at the things. So both the vacancies have been obtained. 0, 0, whatever you call it. So I think the first reading is done. With the first reading of all these things, we have got so much of arrangement. Now let's go for the second reading. Y likes neither brown nor red. Y likes neither brown nor red. See, Y will come in the bottom row, row 2. So Y will either come here or here. Yes or no? Brown or red are not for Y. So Y either takes this seat or this seat. I don't want to take the two possibilities now. I mean, I don't even have the space. So let's go to the next one. W and V are not immediate neighbors. Okay. D is immediate neighbor of A and C is done. One of the vacancies for the right of is done. C does not like black color. C does not like black color. Okay. Later stage. There's only one seat between green and cyan. Okay. I think this point is useful. We have used this, right? There's only one seat between green and cyan. Pictorially we have represented. Let's try and use that now. See, look at it. There is only one seat between green and cyan, he says. Is it possible in the top row? No. Because in top row we don't have two alternate seats vacant for colors, right? You see, these two are vacant, I mean, with respect to color. But green and cyan cannot come here because there should be one gap between those two colors. And suddenly after two colors, we have one more vacant color here. I mean, one more empty space here. So basically, green and cyan cannot be for the top row. You understand? Otherwise, this kind of an arrangement is not possible. Green dash cyan or cyan dash green. Anything can be taken. Green dash cyan or cyan dash green. It is not possible for the top row. It should come in the bottom row only. Yes or no? In the bottom row also, can green or cyan come here in this position? No. Because then immediately this one should be cyan or green. Not possible. So green and cyan have to take these two positions only. You getting it? We want two alternate seats without any colors. Two alternate seats without any colors. For this to happen, for this pictorial representation, what do we want? We want two alternate seats to be without colors. Right? Two alternate seats to be without colors. So I think those two have to be this, green and cyan. You will either be green or cyan. Yeah? Very little space, but let me write down. There is no other way. Yeah? Let me just note that. This could be green. This is anyway vacant seat. This is green and this is cyan. Remember, it is interchangeable. We can interchange these two. It can be green dash cyan or cyan dash green. It's not confirmed yet, but definitely these two seats are blocked for green and cyan. I think now I can go back to the okay, Y neither likes brown or red. Y can come anywhere. V and W are not immediate neighbors. Fine. One of the four vacancies for the right of E. C does not like black color. C does not like black color. Fine. Those are one seat between green and cyan. This is also done. V likes either black or blue. Now look at this. Look at this. I think we have got some information. We know that V, the person V, will come in the bottom row. He says V likes either black or blue. See, V has to come in the bottom row. Is this black or blue? No, this is brown. This is red. This is green. And this is cyan. This is anyway a vacant seat. V likes either black or blue. So the only possibility is V has to come here and black or blue will come here. Other seats are only blocked with some other color. So V's position is fixed. V's position is fixed. I think now if I go back to the previous statement, it said Y likes neither brown nor red. Y will not be coming in these two seats because Y likes neither brown nor red. Y does not like these two colors. So the only possibility is Y has to come here. Y may either like green or cyan. Again, remember these two are interchangeable. Then W and V are not immediate neighbors. W and V are not neighbors, immediate neighbors. So if W cannot come here, then W has to come here. I think bottom row is also done with respect to persons. Who were the persons? U, V, W, X, Y. U, V, W, Y are done. This is vacant seat. This has to be X. So persons are arranged in both the rows. Persons are arranged. What is only left out is the coloring now, right? Yeah. What else can be done with respect to colors now? V likes either black or blue. Either black or blue would come here. Okay. Okay. Look at this. There was one point with cyan and indigo, right? The one who likes cyan is diagonally opposite to the one who likes indigo. See, cyan should be diagonally opposite to indigo. So I think cyan has to come here only for you. Then B can take indigo. Cyan cannot come for Y. See, for cyan cannot come for Y because diagonally opposite to Y, I mean diagonally opposite means what? Two ends of the corner, right? I mean this is like a rectangle, right? It's like a rectangle. Diagonally opposite are these two ends or these two ends. This with this or this with this. So cyan and where is that other color? Indigo, right? Yeah, cyan and indigo are diagonally opposite. So cyan has to come here. Then B will become indigo. So it is fixed now. I can remove that double-headed arrow. Y likes green, U likes cyan. Yeah. Done. I think we are done. Just two more colors to be done for V and for C. What do we know? V likes either black or blue. V will like black or blue. Somewhere it was given some color for C, right? C does not like something. I remember to have read that. C does not like black color. Look at this. Of all the colors, I think 8 colors have already been fixed. Indigo, pink, beige, white. Where are the colors? Indigo, pink, beige, white. And then brown, red, green, cyan. Brown, red, green, cyan are done. He says, where is that point? C does not like black color. C does not like black color. C does not like black color. The only two colors available now are blue and black. C does not like black, so C has to like blue. And if C likes blue, then V likes black. Done. The arrangement is done. So the final arrangement is this. I know it's very clumsy, but yeah, owing to the shortage of space, this is what it is. So if I have to read out the arrangement, it is as follows. In row 1, we have B, vacant seat, A, D, C, E. In row 2, we have V, X, W, Y, vacant seat, and U in that order. For row 1, the colors are indigo, then space, then pink, beige, blue, white. This is blue, by the way, right? Blue and white. For row 2, we have black, brown, red, green, then space, and then cyan. And I think there's one question that we have, right? Who likes green color? Who likes green color? Green color is Y. Y likes green color. And there will be, I mean, I don't have the other questions. Abhi had not posted the other 4 or 5 questions here. He has posted only one question. But like I said, answering the questions is very easy. Once you have done the arrangement, answering the question would be very easy, right? Yeah. Once you have done the arrangement. So that's the final arrangement. I guess we have satisfied all the conditions, right? No condition got violated here. If you want, we can very quickly check. But not really required. I mean, we have come condition by condition. So that's the final arrangement. And like you can see, it is complex. It takes a little bit of time. So you have to be very, very careful when you're doing this. In the first place, you should not write at all, right? I mean, like I always say, the best way to solve complex arrangements or complex linear or complex circular arrangements is to skip it for the moment, right? Solve the other questions, other easier questions, and if time permits, come back. And whenever you come back, out of the 3-4 arrangements that you have in the exam, choose the one that you feel like is the easiest one. This doesn't really sound very easy, right, from the first few statements. But yeah, if you have no choice, you have to try it. Do it very carefully. Do not assume that it will take so much of time for solving it. Yeah, because I was not solving it, I was explaining it to you, so it has taken this lot of time. When I have to solve it myself, I'll save at least half of the time, right? I mean, there's a lot of analysis that is done, lot of things that we try out mentally. I cannot try it mentally because I want you to understand what I'm thinking, so it has taken so much of time. Yeah, but when you do it yourself, or when I do it myself, I may take about 5-6 minutes to complete the arrangement. The key takeaway here is the start of the statement. The start of the arrangement is very, very important. Which statement that you choose, right? Try to choose a statement that gives you a solid start. Only 2 cases, not more than that. And try to choose a statement which is connected to the other statement, like pink. Pink is given in 2-3 different statements. So if I use pink as my starting point, I'm just giving an example, then I can also try out the other possibilities, right, other statements, and see which one works and which one doesn't work for me. So overall, if you see, we tried with the first two, one of which got ruled out, and then only one is left. When we continue trying it out, we find that there are two more possibilities. We try those two as well. Okay, so that's about this question on complex linear arrangement, which was posted by our student Abhi Tripathi in the reasoning discussion forum. Okay, Prerna has got a question here. Prerna says, it was mentioned in the first para that each member seated in a row faces another member of the other row. Please clarify. Okay, I know. Yeah, so the point there could be that when you say each member in a row faces another member in the other row, does it mean that the two vacant seats are opposite? Not really. While that statement, if you take it in the literal sense, it actually means that, because if each member in a row has to face another member of the other row, then the two vacancies have to be opposite to each other. But that's not the case. That's not how it is. I mean, I'm sure we'll not get the solution if you consider that very strictly. Yeah. Usually when there are no vacancies, then it holds true. Right? If there are no vacancies, then we always say that yes, one person in each row faces one person of the other row. But here in this case, it should be like, one person, each person of a row faces another person or a vacant seat in the other row. See, the point that is being made there is that the seats are not disaligned. The seats are not disaligned. Like 1, 2, 3, 4, 5, 6. In the bottom row, 1, 2, 3, 4, 5, 6 is somewhere there or somewhere here. That's not the case. 6 seats and 6 seats. The seats are facing opposite to each other. The persons need not really face opposite to each other. Right? I mean, it should actually be changed. The right way to present the question should be, instead of saying each member seated in a row faces another member of the other row, he should say each seat in this row, each row faces the seat of the other row. See, again, members facing each other is also important, because sometimes you see, right, the person who is seated opposite to you, if the seats are disaligned, then what do you mean by person who is seated opposite to you? It could be any person, right? So the whole idea is to tell you that it's a proper arrangement of 6 seats in first row with 6 seats in the other row, where each seat is opposite to each other. If there are no vacant seats, we can say each member is opposite to each member is opposite to some other member of the second row. Okay, so I think the question has to be framed a little differently for that. I mean, you, instead of saying each member, you should say each seat is opposite to some seat. So that's about this question arrangement. I think we are good for the day today. Thank you all for joining us in this session. We'll meet again on the next Saturday with your doubts clarification session. It will either be on English language or reasoning and aptitude together, reasoning and quantitative aptitude together. Okay, and I would just like to remind you all again that we have uploaded a lot of new videos in your general awareness section of SSC exam prep program. Please go through those videos and share your valuable feedback with us, so that if there are any more changes we think will help your learning get better, we will make sure that we do that. Okay, thank you once again. Keep practicing and take very good care of yourselves. I'll meet you all in the next session. Bye.